Imagine a place in the universe so dense, so powerful, that not even light, the fastest thing in existence, can escape its grasp. This is what we call a black hole, one of the most mysterious and extreme objects in the cosmos. Despite the name, a black hole isn't actually a hole at all. Instead, it's a region where matter has been crushed down to an unimaginably tiny and dense point, creating a gravitational pull so intense that nothing, not even light, can break free. To put this into perspective, imagine if our sun, which is over 1,000,000 times larger than Earth, was squeezed down to the size of a small city. The gravity from such a compact object would be so overwhelming that it would warp the very fabric of space and time around it. At the very center of a black hole lies the singularity, a point where density becomes infinite and the known laws of physics simply cease to function. Surrounding this is the event horizon, an invisible boundary marking the point of no return. Once anything crosses this line, it's lost to the black hole forever. Black holes are born from the dramatic deaths of massive stars. When these stars run out of fuel, they collapse under their own gravity, triggering a supernova explosion. What's left behind is a core so heavy and dense that it warps space-time itself, forming a black hole. These cosmic phenomena act as one-way doors to the unknown. Anything that gets too close, stars, planets, even light, gets pulled in, spiraling toward the event horizon and vanishing from our universe. Black holes captivate our imagination because they push the boundaries of what we know about physics. They challenge our understanding of space, time, and reality itself, forcing us to rethink the very nature of the universe. Inside a black hole, the rules of nature as we know them break down. Matter is stretched and compressed in a process called spaghettification, and time itself seems to slow to a halt. Black holes are the ultimate testing ground for our theories about how the universe works. We can't see black holes directly since they swallow all light that comes near, but we know they're there because of the dramatic effects they have on their surroundings. Stars and clouds of gas orbit invisible points, moving in ways that can only be explained by the presence of a massive unseen object. Sometimes black holes power spectacular jets of energy that shoot out from the centers of galaxies, traveling millions of light years into space. These jets, and the strange orbits of nearby stars, are all clues that reveal the hidden presence of black holes. These invisible giants don't just lurk in the darkness, they play a crucial role in shaping entire galaxies. Their immense gravity helps sculpt the structure of the cosmos, influencing how galaxies form, grow, and evolve over billions of years. Even though black holes are shrouded in mystery, their presence is felt everywhere. They are silent architects of the universe, subtly affecting the motion of stars and the fate of galaxies. In many ways, black holes are the universe's ultimate monsters, devouring everything in their path, yet holding the secrets to some of the deepest mysteries in science. To study black holes is to peer into the heart of both creation and destruction, and to seek answers to questions about the very nature of reality itself. They remind us how much there is still to discover in our vast and wondrous universe. What would it mean to demolish a black hole? Imagine standing at the edge of the most mysterious and powerful object in the universe, contemplating its complete erasure. The very idea stretches the limits of our imagination and challenges everything we know about physics. It's not like destroying a building where you can see the walls crumble and the structure fall apart. With a black hole, there's no physical shell to break, no beams to cut, no rubble left behind. Black holes have no surface, no structure to dismantle, just pure concentrated mass and energy. They are regions where gravity is so intense that nothing, not even light, can escape. The event horizon marks the boundary, but inside, all matter is crushed into a single, infinitely dense point. To destroy one, you'd have to erase its mass, undo its gravity, and remove its event horizon. This means unraveling the very fabric of space-time that the black hole has warped around itself. It's the ultimate act of cosmic engineering, like trying to unbake a cake or unmix colors. An impossible task because the ingredients have fused into something entirely new. But mass and energy can't just disappear, they must go somewhere. If you could somehow force a black hole to give up everything it has swallowed, the release would be unimaginable. Demolishing a black hole would unleash all the mass and energy it's consumed, possibly in a universe-shaking explosion. The energy released could outshine entire galaxies, sending shockwaves across the fabric of space-time. This act would challenge the most fundamental laws of physics, like the conservation of mass and energy. It would force us to rethink our understanding of how the universe works at its deepest level. It could even violate the cosmic censorship hypothesis, exposing a naked singularity, a point where physics breaks down and our equations no longer make sense. Such a sight has never been witnessed and may not even be possible according to current theories. Such an event would unleash chaos, a tear in the rulebook of reality itself. The very structure of space and time could be disrupted, with unpredictable consequences rippling outward. Destroying a black hole isn't just about removing an object, it's about rewriting the laws that govern the universe. It would be as if the universe itself had to update its operating system to account for this impossible act. The consequences would be unpredictable, possibly catastrophic. Galaxies could be torn apart, stars flung into intergalactic space, and the balance of cosmic forces forever altered. The universe hides singularities for a reason. These cosmic secrets are shielded from view, perhaps to protect reality from their raw, untamed power. Demolishing a black hole could unleash pure chaos into the cosmos, rewriting the story of existence itself, and reminding us just how fragile the order of the universe truly is. How could we even attempt to destroy a black hole? The very idea sounds like something out of science fiction, a challenge that pushes the limits of our imagination and technology. Black holes are the most extreme objects in the universe, with gravity so intense that not even light can escape. So is there any way we could even try to take one down? Any matter or energy we throw at it just makes it bigger. Its gravity is the ultimate defense. The more you feed a black hole, the more massive and powerful it becomes, devouring everything in its path. It's like trying to put out a fire by throwing gasoline on it. What about antimatter? It's no use. To a black hole, mass is mass and it only grows. Antimatter and matter annihilate each other elsewhere, but inside a black hole, both simply add to its mass, making it even more unstoppable. Could we spin it too fast, destabilize it somehow? The energy required is beyond anything we could ever produce, even if we harnessed the power of entire stars. The laws of physics set hard limits that we simply can't overcome with current or even foreseeable technology. The only process that might work is Hawking radiation. Black holes slowly evaporate over unimaginable timescales. This quantum effect causes black holes to lose mass, but it's an incredibly slow process. For a solar mass black hole, this would take longer than the age of the universe. We're talking trillions upon trillions of years, far longer than humanity has existed or likely ever will. For supermassive black holes, it's even slower. These giants could take a mind-boggling amount of time to evaporate, outlasting stars, galaxies, and perhaps even the universe itself. We can't speed it up, we just have to wait. There's no known way to accelerate this process, no cosmic shortcut or technological trick. The universe is already demolishing black holes, but on a timescale that dwarfs human history. Black holes are slowly fading, but their demise is written in the farthest chapters of cosmic time. Every practical method we can imagine only feeds the beast. Anything we try just makes the black hole stronger, more massive, and more impossible to destroy. Black holes are the ultimate cosmic fortresses, impervious to our efforts and protected by the very fabric of space and time. Their destruction is beyond our reach with current science. We are limited by the laws of physics and the tools we have at our disposal. For now, we can only observe and wonder, peering into the darkness and dreaming of what might one day be possible. Suppose we could instantly erase a black hole. What happens next? The gravity holding nearby stars and planets vanishes, releasing them from orbit. The galactic core would erupt into chaos, stars flung into space like cosmic billiard balls. Collisions could trigger new stars or catastrophic explosions. The orderly dance of the galaxy's heart would become pandemonium, but the real spectacle is the energy release, or the black hole's mass converted to pure energy in a colossal explosion. Gamma rays and radiation would sterilize everything for light years. Any nearby civilization would be vaporized in an instant. The demolition of a supermassive black hole would be a galactic-scale disaster. It would rewrite the fate of thousands of star systems in a flash. Destroying a black hole would shake the very fabric of space-time. Gravity is the curvature of space-time. A black hole is an extreme distortion. Remove it, and space-time snaps back, unleashing a gravitational tsunami. These waves could tear apart planets and stars, distorting reality itself. Time near a black hole slows down. If it vanished, time would suddenly synchronize, with unknown consequences. The most terrifying risk, exposing a naked singularity, where physics breaks down and unpredictability reigns. Information could emerge without cause, violating the principles of reality. The universe seems to forbid this for a reason. Demolishing a black hole could scar the cosmos in ways we can't imagine. It's a storm in the very structure of existence. To grasp this, imagine a whirlpool. Once you're too close, escape is impossible. A black hole is the ultimate cosmic whirlpool, pulling in space, time, and light. Trying to destroy it by adding more only makes it stronger. The energy released would dwarf every explosion on Earth, converting mass directly into energy. Imagine a merry-go-round. If the center vanishes, everything flies outward, just like stars around a black hole. Remove the anchor, and chaos erupts. Space-time is like a stretched trampoline. A black hole is a deep well. If it vanishes, the trampoline shudders violently. So would reality. Every point in space and time would feel the shock. There's no real-world equivalent for this level of violence. It's a cosmic event beyond human experience. The universe would never be the same. Can we demolish a black hole? Physics says no. General relativity describes black holes as stable, final states for massive objects. The no-hair theorem means black holes are simple, just mass, spin, and charge. There's nothing to break, no weak points to exploit. Destroying one would mean reversing its formation, which seems impossible. The information paradox asks if information is lost in black holes. Hawking radiation suggests it might slowly leak out. A forced demolition would have to account for all that information. The laws of nature, energy conservation, entropy, space-time, are the universe's firewalls. Destroying a black hole would require new physics, beyond Einstein. It would mean rewriting the source code of the cosmos. Supermassive black holes are the anchors of galaxies, including our own. They shape galaxy formation and evolution, holding the core together. Remove one and the central hub would slowly disperse, unraveling the galaxy's structure. Star formation would change, and the galaxy would lose its heart. Black holes recycle matter, spewing jets that trigger or suppress star birth. Without them, the cosmic ecosystem would be thrown out of balance. The universe would become more chaotic, less structured. Black holes may be essential for stability and the formation of life. Their existence shapes the cosmos as we know it. Without them, the universe would be a very different place. Black holes are not just cosmic oddities, they are pillars of the universe. They push our theories to the limit, forcing us to seek deeper understanding. The paradoxes they present point toward the next revolution in physics. Every new observation brings us closer to answers about reality itself. Black holes inspire curiosity and remind us how mysterious the universe is. They represent the edge of the known, the dark shores of discovery. As long as they exist, we will keep searching for answers. The journey to understand black holes is the journey to understand ourselves.